Okay, our topic today is substitution and equivalence. So we're talking about algebra expressions, and what we're after here is substitution is about the idea that we can replace a pronumeral with a number. Okay, that's what substitution is about. Equivalence is about having two expressions that are the same as each other. In other words, if they are equivalent, they're going to be the same regardless of the numbers that you substitute. So let's use an example. Let's say that I had 7a plus 2b plus 5. Okay, an expression has three terms. Talked about that. Let's say that we said a equals 3 and b is equal to 4. We can substitute those numbers in place of the pronumerals. So we're going to do that. We're going to say 7. Now this is another way to say, because remember this 7a is 7 times a, okay? And a is 3, so we're going to put that 3 there. And this is another way of saying 7 times 3. We could write it out 7 times 3. That's another way to say it. Plus 2. And what is b equal to? B is equal to 4 plus 5. So 7 times 3 is 21, plus 2 times 4 is 8, plus 5. So 21 plus 8 is 29, plus 5 is 34. So we have substituted those two values in place of the pronumerals. Okay? Now, similarly, we can look at, and I'll give you an example of this we'll come back to equivalence in a second, but there are two mathematical processes or laws that we can use to figure out whether two expressions are equivalent or not. And those are called the commutative law, or the commutative property. And the commutative law says that if I add things together, it doesn't matter which order they're in. So the law is written by this way: a plus b is the same as b plus a. And I think you already know this intuitively. If I say 3 plus 4, that's the same as 4 plus 3. 7 plus 5 is the same as 5 plus 7. It doesn't matter which way we put those. The same is true with multiplication. A times b is equal to b times a. So it works with addition and multiplication, but not with subtraction and division. Think about it. 4 minus 2 is not the same as 2 minus 4. 6 divided by 3 is not the same as 3 divided by 6. Okay? Now, the other law that we can use when we're talking about equivalence that's helpful is called the associative law. And like commutative, the associative law applies to addition and to subtraction, and it talks about brackets. So, for example, a plus b in brackets plus c means we would normally do a plus b before we added the c. But the associative law says that if they're all addition, then it doesn't matter where the brackets are. We could say a plus bracket b plus c, and those mean the same. We can move the brackets if they're all addition. The same is true if they are all multiplication. A times b plus c is the same as times c. It's the same as a times b times c. Now, how do we use this? We've already given you one example, but let's do another substitution. This time we're going to use x and y instead. We're going to say that x is equal to 3 and y is equal to 6. Now I'm going to give you a couple of expressions, but we'll see what happens. 5x. That's an expression. What does it mean? It means 5 times x. So we can substitute in 3 for the x and say 5 times 3, and that means 15. So if x is equal to 3, then this expression is equal to 15. Let's try a little bit harder expression. Let's say we use 5x squared plus 2y plus x. Now again, we can substitute. This time we'll use a different color to make it more obvious. you can say 5 times, and what is x equal to? We said x is equal to 3. Put the 3 in there. Squared plus 2 times, and y is equal to 6. Oops. Plus, and x again is equal to 3. So what do we have here? We have 3 squared. I have to always do the exponents or powers first. 3 squared is 3 times 3 is 9 times 5, 45, plus 2 times 6 is 12, plus 3. Now remember our associative law and our commutative law, we can add these together in whichever order we want because they're all addition. So I would say 12 plus 3 is 15, that's easy, and then 15 plus 45 gives me 60. If we wanted to, we could change that order and we could say 45 plus 12, which is 57, and then add 3 to that and we get 60. That's how those work. Now when we talk about equivalent expressions, let's use an example. Let's say that we had x minus 3 and 3 minus x. And in order to check whether they're equivalent, there are laws of arithmetic we can use, like these, but also we can usually just try in a number of values, and I think you'll see that these two are not equivalent. Now if x is equal to 0, then that doesn't work, does it? X minus, 0, even then, 0 minus 3 gives me minus 3. 3 minus 0 gives me positive 3. So those two are not equivalent. If x is 3, they would be the same. 3 minus 3 is 0, 3 minus 3 is 0. But if I try almost any other, in fact, any other number other than 3, then we'd see that they didn't work. What if we tried 2? 2 minus 3 is minus 1. 3 minus 2 is positive 1. So those are not equivalent expressions. These two are not equivalent. What if we had these two? A plus B and b plus 2a minus a. And if we pick any two numbers, we'll see that these two expressions are the same. Let's say that we said a equals 1 and b equals 2. What do we get? 1 plus 2, that's 3. Over here we would get 2 plus, what's 2 times 1 is 2. Take away 1 is 1, so 2 plus 1 is 3. Okay? We can use bigger numbers. Let's say we wanted to use something like 10 and 5. 10 plus 5 is 15. That would give me 15. And over here we would have 5 plus 2 times 10 minus 10. 2 times 10 is 20. So 5 plus 20 is 25. Minus 10 is 15, which is the same thing. These two expressions are equivalent. And that is equivalence and substitution.